Welcome to another LMI demo video showing the Surface Plane Advanced tool used to best fit a plane feature from 3D scan data. Our demo setup here uses a Gocator snapshot sensor model 3210, but this tool is available on all Gocator models that generate a 3D surface. We'll be using live scan data, as you can see if I take a scan of my hand. But let's go ahead and scan this metal plate with a knob in one of the holes. Our sensor is aligned to our tabletop, so if we enable part detection with a minimal height threshold, we can remove the background from our scan, letting us focus on just the part. Once we have a good scan, we can add a Surface Plane Advanced tool from our measurement tool list. Now I should point out that LMI has had the Surface Plane tool for many years, but the Surface Plane Advanced tool, added in Gocator software version 6.3, offers several improvements, including percentile filtering to remove high and low outliers, multiple regions and variable region shapes, and anchoring with Z-angle. And we can see the effects of using some of these new features here by tuning the percentile high and percentile low parameters. By excluding these outliers, I'm able to get a more accurate plane fit. The Surface Plane Advanced tool returns several measurements about the plane it fits, including XY angle, Z offset, error standard deviation, and more. Here I have to slightly change my percentile high value to get a true fit. I can even focus on the high points, giving me a plane along the top of my knob. So that's pretty much it for setting up a Surface Plane Advanced tool. Typically, you use this in combination with other measurement tools. So let's go ahead and build a simple measurement program looking at the lid on a Play-Doh canister. For this, we'll set our height threshold a little bit higher and take a new scan. And there's our lid. Let's now set up some tools to measure it. We already have a Surface Plane Advanced tool that's finding the top of the lid, so we can rename that. And then we'll change the region. Instead of a rectangle, we'll set it to be the entire surface. And then we'll duplicate the tool and rename it. And with this Surface Plane Advanced tool, we'll find the bottom of that lid. And we just have to change our percentile high and low values. They're working well. If we take another scan of this part at an angle, you should see the planes are still correct. Our top plane along the top of the lid and our bottom plane along the bottom of the lid. Let's add a surface bounding box tool. This is just going to locate the center of our part. report back an X and a Y location, which can be used as an anchor for any subsequent tools. Let's add a surface circular edge tool. This is going to measure the OD of our lid. We'll want to anchor that to the bounding box tool we just set up. Adjust the region and tune some of the parameters, including caliper count and caliper length. And we're finding our circle. But a cool feature here is the ability to project that onto a reference plane. And so we'll project it onto our top plane that we've already found. And everything still works, even if we move the part, we take an image. Let's add one final tool. We'll add feature dimension to measure the distance between those planes that we found at the center of our lid. So we'll reference a point and a plane and get a distance measurement between those and enable some graphics as well. And by moving the part around, changing the angle, we can get a feel for the repeatability and accuracy of this tool. That height stays at about 7.1 millimeters. So that's a brief overview of Surface Plane Advanced, LMI's newest software tool for accurately fitting a plane from 3D data.